I think actually Bitcoin failed to the promise that it will be this peer-to-peer decentralized payment system, but it failed not on the what it promised, but more on the scalability part. It's just too slow for humans and infinitely slow for AI to adopt. Even 100,000 TPS, even 200,000 TPS, even 500,000 TPS, it's too little for the future that is already here. AI agents, we need to pay each other, micropayments for microservices, fractions of cents. They need to be instantaneous and they need to be dirt cheap. Blockchain simply cannot sustain this economy.
All right, here we are with Grigore Roșu, co-founder and CEO of PiSquare. Grigore, welcome to the Defiant. Great to have you.
Thank you for having me.
So I'm very curious about PiSquare. It's a network that's not a blockchain and that is promising record kind of performance and execution. That's kind of the brief gist, but we'll dive straight to it. So Grigore, I know you have a really impressive background in crypto. You've built some of the most important formal verification companies with runtime verification, the K framework. So what made you want to build FastSet's?
I'm also a professor of computer science at University of Illinois, Urbana-Champaign, where I teach programming languages and formal verification. And in general, techniques that help us prove the highest level of rigor that programs do what they are supposed to do. And I built runtime verification back in 2010 when blockchain was not even a thing, in order to formally verify mission-critical software that flies in airplanes or in cars or in spacecraft. I also worked at NASA previously. And the K framework came out of that effort where we needed a very rigorous way to say what a programming language is. Because without being able to say what a programming language is, we cannot reason about programs. We cannot say when a program does what it's supposed to do. So that's how I started. That's what I've done all my career. And last year, I decided to start FastSet's, actually the company PiSquare, and FastSet's as a product, the main flagship product of PiSquare, because we've seen literally all the dirt in Web3 through runtime verification, through security audits, all the types of bugs, the poor designs, the slow implementations. And we decided to do things right. And that means two things, in my view. First, unlimited speed. Performance should not come at the expense of correctness. And second, universality with respect to languages. We should be able to use all programming languages in Web3. So that's why we built FastSet's, in order to bring performance and universality to Web3.
What you're building is actually not a blockchain. So can you explain what it actually is and why does it still fit within crypto?
It is not a blockchain in the sense that it does not require or enforces or builds a chain on transactions, a total order on transactions. It is the exact opposite of that. It is massively parallel. It is a massively parallel verifiable settlement layer. And one metaphor that I like to use here, if you don't mind, is that of athletes trying to run on a football field from one end of the football field to the other, right? Imagine that you have, 50 athletes that are supposed to run from one end to the other end of the football field. They will run probably, if they are top-notch athletes, probably in 10 seconds or so, plus minus half a second, right? Some of them could be a bit slower or faster than others. Now imagine this. Imagine that you put a door in the middle of the football field. And everybody has to run through that door. No matter how good they are, no matter how trained they are, that door will create congestion. And that will slow down massively their total trip, right? All of them in order to get on the other side of the football field. So that's what blockchains do. These athletes are our transactions. We all want to do transactions. We all want to do payments, transfers, vote, auctions, bids, and so on. And we all have to go through this narrow door that enforces a total order, these sequencers, the infamous sequencer that forces everything to go in line and slows everything down. Now, imagine that you don't have the door at all, and everybody runs at their own speed from one end of the football field to the other. It will be much, 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 much faster. And we found a way to do that. It was not clear how to do that initially, but we found a way to do it. And that's what FastSet's is. It's a settlement layer at the speed of the internet.
So without getting too technical, can you explain how you actually achieve this, how you can achieve this uncapped throughput.
Again, parallelism is the key word here. Actually, in computer science, in the theory of concurrency, we call it embarrassingly parallel system, which means that every single transaction, in this case, can be handled, which means validated, settled, finalized, completely independently and in parallel with all the others. So it is all limited only by the bandwidth and the computing power of each validator. But validators don't need to talk to each other, which is very unique to FastSet. Because in blockchains, validators need to do lots of communication in order to make sure that they enforce that sequence, the total order, and everybody is in agreement with it. So this is one aspect which is in sharp contrast to blockchains. And of course, you have to maintain some discipline to make sure that the validators will eventually see the exact same state of the system. And this is what the protocol proves. We spent a lot of time, more than 3 years, to mathematically prove everything correct. We had the first idea in 2020, and we only implemented it a few months ago, finally. The proofs are pretty tricky, but in the end, eventually, all the validators will reach the same state, and notably, they do not need to communicate with each other. They do not need to slow each other down. And transactions issued by different clients, they don't need to slow each other down either.
So, okay, so you achieve what blockchain achieves through a different mathematical path,
Yes.
I guess.
Yes.
How can you make sure that there is no kind of malicious transactions, that there's no double spend? And related to that, like, how frequently is the system ensuring that all of the validators are agreeing on the same state?
Yes, very good question. Let me start by telling you a fact. More than 90% of all the transactions on blockchains do not require a total order. They are completely independent of each other. Let's go back to that metaphor with the athletes running on the football field. So each of them runs in sequence. Okay, you go one step, then the next step, then the next step, right? It's a sequence for each athlete. But all of them run completely independently of each other. They all step at the same time in parallel. So this is how you avoid double spending. Double spending is a property of one account, not multiple accounts. So you are supposed to not double spend. What Bitcoin proposed, the amazing idea, one of the amazing ideas underlying Bitcoin, was that of a chain of transactions. So Nakamoto, even in the abstract of the paper, said that to avoid double spending, we enforce a chain on transactions, a total order on transaction. And of course, if you have a total order on transactions, then you cannot double spend because it's either one transaction first or the other. You cannot fork, you cannot double spend. But again, this is a property required for each individual account. Of course, if we now go back to the athletes, if everybody goes through one door, right, there will be only one step at a time through the door. Right? So we know that there is nobody can. Of course, you cannot fork as an athlete, but the general principle is that you can have local consistency, local order, local total order. Basically, for each account, you can have a total order without enforcing a total order on the entire universe, which is what blockchains do, and Bitcoin does as well. Of course, if you have a total order on the entire universe, then every account will be totally ordered, and so we are completely safe. But that is too strong as a property. It's a very high price to pay. And of course, the question is, as you rightfully asked, is that correct? How can we make sure that bad things don't happen? And as I said, we spent a lot of time to prove all this, and our white paper is available on the website. And we prove 4 main theorems: consistency, monotonicity, liveness, and determinism. These are properties that you want to have for a replica-based distributed system, which is what we implement eventually. And all these properties also hold for blockchains. And this is the properties that you need, not the blockchain.
So does the system remain uncensorable, incorruptible, permissionless, those the kind of main features?
All those properties can be derived from these 4 main properties. And so liveness implies censorship freedom. Consistency, determinism implies that you cannot have chaos. Everything is eventually organized. So the main difference conceptually is that with blockchains, if you freeze the entire network at any given moment, all the validators will have exactly the same state. Okay? But that is not necessary. What you need, and this is the property that FastSet has, is that eventually, when all the transactions get clear, everybody will have the same state. But at any given moment, they may have different states. And that is okay. We have to understand that. It is okay that different validators have different states at any given moment. But
because they're each confirming different transactions, like in parallel.
exactly,
Right?
they may receive the transactions from the accounts in different orders. But because of that, they may update their states locally differently. But eventually, once they process all the transactions, they will get to the same state.
And eventually, when does this happen, like periodically at a set time, or when do
This is another beauty of the protocol, is that there are no blocks anymore. There is no synchronization required anymore. One interesting example could be voting. Suppose that you and I vote, and then suppose that we vote for the same cause. So in the end, what you and I do, we increment a counter in a program. You add one vote and I add one vote. And now we submit our votes, let's say, to 1 million different validators. We broadcast our votes to 1 million different validators. Some validators will receive your vote first and then mine. Others will receive my vote first and then yours. But they both, all of them in the end increment the counter twice. So in the end, the result is the same. There will be +2 votes once both you and I vote. You see, while on a blockchain, what will happen is that the sequencer will decide that your vote goes first and then mine, even though both of them are before the deadline. But for some reason, the sequencer decides to order your vote before mine. And now all the validators have to follow the same discipline. Everybody will have to increment in exactly the same order. That's unnecessary and expensive. That's a super expensive thing to do. This synchronization this is called strong consistency in distributed systems. It's one of the most expensive and unscalable operation ever. And for some reason, blockchain decided to implement exactly that.
How decentralized can this system be? Can anyone be a validator? What are the requirements for it?
Yes. So, of course, initially, we will maintain some discipline, but long term, anybody can join. There will be some discipline. In order to join, you have to have a stake. So you have to make sure that you are truthful. If you lie, you'll be slashed and all that. But yes, it's completely permissionless. Everybody can join the network as a validator. But you need to have, so the way the protocol works is that clients or applications, they broadcast their claims with proofs. Like a payment is a signed transaction. And validators validate, and then they send back, not to each other, but they send back to the client or a proxy of the client. They send back their signatures. And now the client has to aggregate the signatures and get a quorum. The validators who are in the quorum will be paid. They will share the fee, the transaction fee. So the validators are incentivized to be fast and truthful. If you lie, you'll be slashed. If you are too slow, you will not get paid. So that's the general principle. And you can join at any time, the network.
Okay, so it's very similar to proof of stake.
Yes.
Validator stake, they get slashed if they misbehave or if they're not performing, and they get paid for the transactions that they confirm.
Yes. But again, they don't need to talk to each other. They don't need to synchronize.
Right.
And there is no proposer. There is no proposer either, and there are no blocks.
What about tokenomics? Like how is the token issued?
So the validators, it's same like on blockchains. There will be staking. You can stake your tokens, and you will get staking rewards that come from fees. And actually, there is an additional risk-taking mechanism. There is also, so the network also allows verifiers in addition to validators. Verifiers can verify complex proofs. Validators only verify simple signatures and settle. But verifiers can verify complex proofs and even do KYC verification or AI model inference verification, arbitrarily complex claims. And in the end, the tokens will be staked in validators and restaked in verifiers. And that's the issuance. And we have a formula, which is a mathematical formula, how we issue tokens, which is, interestingly, when you issue all the tokens, it will be exactly pi squared, which is 9.8 billion tokens.
That's why your name was that kind of.
No, our name comes actually from proof of proof. It doesn't come from. So it just happens that this issuance mechanism will be. It's called the Basel formula. It's a Basel series, which is the sum of 1 divided by squares. 1 plus 1 divided by 2 squared, plus 1 divided by 3 squared, plus and so on, 1 divided by n squared is pi squared divided by 6. But our name pi squared comes actually from proof of proof, because we have this universal approach to verifiable computing, that we can generate proofs for computations in any programming languages without translating programs to one particular language or VM. And that's where the name comes from. But
And back to tokenomics, do users also need to pay for transactions in gas? So it's like also
I will
starting
tell you,
gas fee?
each transaction will be a transaction. There will be a transaction fee associated with the transaction,
Mhm.
and the validators who participate in the quorum will split the fee.
Okay. And then, so interesting. Like, I've never heard any architecture like this.
Because it's completely decentralized and completely parallel, right? So when you send your claim, you send it to all the validators at the same time, not to one validator, who now has to propose a sequence. No, it's to all of them, and they have to move fast. Nobody cares about nobody else. The validator 1 doesn't care about validator 2. Validator 1 only cares about validating and sending as quickly as possible the signature back.
So this, of course, allows you to have very fast transactions. And right now, I think there's been kind of a surge of new blockchains claiming to have the fastest speeds ever. Mega ETH, I think, is maybe the one of the kind of the trendiest right now. How do you compare with these chains?
So first of all, I really like Mega ETH. Just to be clear, the CEO of Mega ETH was my student, Ilong Li, for 7 years. So we grew up with the same philosophy and the same beliefs, both in terms of formal verification and performance and parallelism. So Mega ETH took a different path where they use parallelism to optimize the otherwise sequential execution of all the transactions. So they still generate a total order on transactions, but they order the transactions in such a way where you can exploit parallel architectures to execute the sequence faster. And for that, you need powerful machines. Our validators are ridiculously cheap, less than $1,000 per machine, 24 cores, 256 gigabytes. These are now standard consumer hardware. Mega ETH computers are pretty beefy, and monads even beefier. And then there is still the issue of verification. How can you make sure that that when you execute at that very high speed, because they still execute things sequentially, and when you execute sequentially very, very fast, the question is, did I have any race condition? Did I have any particular non-deterministic interference in the execution that could lead to a wrong result? And actually, we have a collaboration with Mega ETH where we verify for them all the blocks using the formal mathematical semantics of EVM. And then we settle that transaction, that block on FastSet. And that comes then with a proof that it was executed correctly. And now Mega ETH, unlike other optimistic rollups, can claim instant finality if they want to. We are still working with them to convince them that it is the right way to go. It's a bit risky for them, so they have to first gain confidence in our proofs. But the idea is that they can actually work very well together. But again, I would like to emphasize this main difference between blockchains and us, that for blockchains, parallelism is an optimization of an otherwise sequential execution of transactions. For us, parallelism is the religion, is the axiom. Everything must be parallel. If you need sequentiality, which happens in 7% or so of all the transactions that we've ever seen on blockchains, like Uniswap, for example, that's a classic sequential algorithm. You cannot mess up with that. Then you can program sequentiality in the application that runs, on the parallel network. Back to our metaphor with the athletes, an athlete is a sequential thing running step by step by step. Yes, they can program and they can train their sequentiality however they want, but they don't have to interfere with the other applications that do not need sequentiality. So that's the idea.
That leads me to my next question, which is on what applications do you foresee will be built on FastSet? And related to that, if you can explain whether building applications on FastSet is the same as building applications on blockchains. Like, can any developer just come and, run code permissionlessly on smart contracts? Like, what kind of programming language is used? And what use cases do you think are well suited for your network?
So you asked two important questions. So let me take them one by one, right? So first, what kind of applications we envision? And there is a short-term and a long-term answer here. In the short term, it will be mainly payments and payment systems. So we're already working on integrating X402 and H402 for payments, for humans and AI agents. We need very, very fast payments. And as much as I love Bitcoin and the entire research that led to it, and other blockchains that came after, I think actually Bitcoin failed to the promise that it will be this peer-to-peer decentralized payment system. But it failed not on the what it promised, but more on the scalability part. It's just too slow for humans and infinitely slow for AI to adopt. And blockchains that came after, they kind of improved the performance, but not too much. Mega is 20,000 transactions per second. That looks great, and it is great. Don't take me wrong; it's wonderful. It's unbelievable that they could push the envelope to that level, more than twice faster than Monad, and it's really. I think Mega is honestly could be the best blockchain technology currently we use. Even 100,000 TPS, even 200,000 TPS, even 500,000 TPS. It's too little for the future that is already here. So AI agents, we need to pay each other, micropayments for microservices, fractions of cents. They need to be instantaneous and they need to be dirt cheap. Blockchain simply cannot sustain this economy. And we need a payment system that is horizontally scalable, that is uncapped in terms of TPS. If you want to make it faster, add more infrastructure, more validators, more bandwidth, more computing power in each validator, incentivize them to do it. And then you got a faster and cheaper network. That's what we need. If Web3 is really here to stay, and I believe it is here to stay, and crypto is here to stay, I think blockchains need to evolve into something else. So that's the first application. And then your second question was, how about languages and what's the user experience when they develop code? So we started Pi² as a universal verifiable computing framework, especially designed, the whole protocol is designed to bring all programming languages, all computing models to Web3. And we have done that, we know how to do that, but I think that can wait a little bit. The payment system goes first, and then programmability. And when we talk about programmability, we mean programmability in all programming languages. Of course, EVM will be available launch of the mainnet in Q2 next year when we plan to launch our network, but all the other languages can come later modularly. You don't have to touch the network, you don't have to change the validators. Validators will not even be aware of the fact that a new programming language has been added to the network. So again, getting back to speed of payments and universality with respect to programming languages. And the user experience will be the same or better because EVM is really pretty poorly designed language. And we've audited the runtime verification, all the major protocols, Aave, Compound, Uniswap, and formally verify them. And they are great programmers, but the languages are poorly designed. And now imagine that developers can use Java or Python or Rust, can use real programming languages that they learn in school, as opposed to these obscure languages that are used in Web3. So
Interesting.
I'm optimistic.
But the first language that you launch is Solidity with EVM. And then you start adding all these more globally.
But you do not but you do not need languages. You don't need to program for payments. So payments will be built in the network. And there is a language called Settle, Set-L from Set language on FastSet, that is a concurrent parallel language, but that needs a bit of skill to use correctly. So we do not encourage unexperienced concurrent programming users to use that language because they may write programs that are not safe when run on massively parallel networks. We provide lots of templates, especially templates for how to implement app chains or blockchains on top of FastSet. And we expect most developers to just pick a particular app chain implemented in a particular conventional programming language like Java or Python or Solidity. And that will have a total order. It's exactly the same mental model of deterministic programming that you expect. But the experts can write parallel programs. Like, for example, if you want a parallel voting smart contract or a parallel auction bidding, where you want billions of people to vote in 1 second. You know, submit their votes in 1 second. Then you need to learn how to do concurrent programming, and Settle is the language for that. But ordinary programmers will just use the conventional programming languages they are used to, and they will have exactly the same experience as today.
Okay, but to really take advantage of the parallel architecture, then you would recommend learning this dedicated new programming language called Settle.
Yes, which we describe in the white paper. And we show lots of examples, more than 20 examples on how to use it.
Okay, and then, so you said mainnet in Q2 of next year.
Yes.
What's kind of the timeline until then? Like, are there ways that people can start participating in the network? Is there a test net? I don't know. Can people already start experimenting around FastSet?
It's a very good question because we are just launching our Devnet this week.
Oh, nice.
So by the time this video will be public, the Devnet will already be there. We encourage everybody watching this to go and give it a try. Go to fastset.xyz and follow the links from there. Play with the wallet, make some transactions, experience the thrill of instant finality. And there are several also applications implemented already on top of FastSet, including this one that I just mentioned with MegaEase. We have a blockchain verification. We call it blockchain verification, the product, and we have it for Ethereum and for Optimism, and we'll have it for MegaEase as well. And we also have another product called OmniSet that allows you to have a unified view of your liquidity on different L1s and L2s. You can now have a unified view on FastSet and then make transfers. You make transfers between L1s and L2s, which are a bit slower because you have to go through a sort of a bridge. But then we can also use this liquidity on FastSet with applications on FastSet. Transfers, for example, on FastSet, which are instantaneous. And we reached already 250,000 TPS on our network. But again, this is uncapped. So it's just what we got right now with our existing network. We hope by mainnet in Q2 to reach 1 million TPS. That's our goal, 1 million TPS by then. And yes, there are blockchains that claim, some, even claim 1 million TPS, but those are very extreme cases in very special conditions. Well, in our network, that is the norm. So it can sustain 1 million TPS when the time comes. Right now, we can sustain 250,000 TPS without too much optimization.
Do you expect to launch with already integrated DeFi partners and protocols?
Yes. So once we have EVM, we don't have EVM yet for the Devnet, but we are going to have it for the testnet. We plan to launch the testnet very early next year, and that will come with EVM programmability. And then you can simply copy and paste Uniswap, the Aves, the compounds, all these programs will run on FastSet. And they will run at the speed of FastSet.
Super interesting. So, okay, with everything that you explained, what do you think about blockchains then? Like, do you think it's an obsolete model?
Yes. I think it was the right technology for pushing the Web3 revolution. Now we understand and believe in Web3, which essentially means that we should own our own assets and nobody else should stay between us and our assets, and we should be able to transfer them and control everything and not be censored. All these properties were made, all these desires were made, or these dreams were made reality by blockchains. So we are very thankful to that. But let's not forget that blockchains are just one particular mechanism to implement these properties. And like everything else, science evolves. And now we got to a point where we can do the same things differently, much better, much faster. This algorithm, by the way, this massively parallel decentralized algorithm for payments that avoids differently the double spending problem was not invented by me and my group. So this was invented by an academic group in Switzerland, the TPFL. But very few people really understood that paper. It was mainly theoretical. So we worked out all the details. It's unbelievable. I think it's one of the best papers that I've read in the last, 10 years. So Nakamoto didn't know about that work, but now we know. And we made one step ahead in that direction. And I think, I already see it. I can feel it. There is resistance, from investors, resistance from scientists, because people are invested financially or reputationally. And, they have all the reasons to keep the blockchain central to the Web3 movement, but they can only do it that much. Better science eventually succeeds. And now the genie is out of the box. This is all published, and I'm here talking about it. Most people, I guess, will ignore me. They'll say, this guy is crazy. I don't care. I know I'm not crazy. And but others will listen, and eventually things will evolve and move to the next level. And yes, I think blockchains will go through that process.
So do you think if a Pi Square succeeds, it will end up replacing blockchains entirely?
So it will not happen overnight, for sure. And I think at least Bitcoin and probably Ethereum as well, and many others, right? Maybe I shouldn't mention names, but they will be here for a while. But I think through applications like Omniset, right, we can now have a unified view of liquidity. And there are slightly different security models and security trust levels. For example, Bitcoin, right, is 51% of the validators need to be truthful. While in our model, we have BFT-based model is 2/3 + 1. So some people may prefer to keep their Bitcoin on Bitcoin for long term because that's more secure in theory and probably also in practice. I don't know about practice because miners are, always an issue also on Bitcoin when it gets to security and trust. But so yes, I don't expect it will happen overnight, but I think people will see the benefits and they will eventually migrate applications to FastSet or something like FastSet, right? So FastSet may be the first step showing that this is possible, and we'll see even better protocols in the future. Also, in terms of parallelism, it's the optimal. You cannot get any better than that, provably. So it's the maximum parallelism that you can get. But I'm sure there will be other attempts. Like everything else, evolution cannot be stopped.
Super interesting. So it's a whole new paradigm on how to run a decentralized network and while still upholding all the properties of blockchains.
Yes.
So thanks so much for coming and sharing this new model with us. Super interesting. We'll definitely continue covering. And yeah, encourage everyone to go and check out the Devnet. And yeah, we'll be watching. We'll see if blockchains die after this.
Thank you so much, Camila. Thank you, everybody. Please go try it out. See it with your own eyes.